All right, chapter 3, the entire chapter is about transformations. And transformations include reflections, translations, dilations, and rotations. And 3 of those are considered rigid transformations. And a rigid transformation, if it gets talked about in your homework tonight, because I don't have an example specifically about rigid transformation, but a rigid transformation is a movement or a turn or something like that that does not change the size of the figure or the angles of the figure. All right, so it doesn't change like basically you have the exact same pictures just moved around somewhere, got twisted around, got reflected, got slid, whatever. Dilations make things get bigger and smaller. That's not a rigid transformation. The other 3 are. So if they ask you, is this a rigid transformation, the basic question you have to ask yourself is, did the sides get a different size or the angles get different angle measures? If that happened, it's not. Otherwise, it is. All right. Again, there's a few more questions involving that. The rest of your homework always involves reflecting today, and they're either going to draw the picture for you or not. I'm going to give you graph paper because you need graph paper for this stuff. So anytime you have to draw anything, draw it on graph. I've got graph paper on this for you. So quadrilateral FGHJ has coordinates F03. So 03 is right here. And G24. Put F here, G here. Make sure you label as you put your points also. Point H is 4,2. And point J is negative 2, 0. Okay. And when you are going to draw a figure, make sure you use straight lines. Make sure you use rulers. I'll pass those out in a moment. But when it says F, G, H, J, that means when you connect the sides, you're going to go from F to G to H to J and back to F. So if I'm drawing this picture, I'm going to go F, G, G to H, H to J, and then back to F. Anytime you're drawing any kind of quadrilateral, triangle, pentagon, anything like that, you want to make sure that you go in the order of letters in the name. All right, so there's FGHJ. This is a quadrilateral. And notice the directions it gives us is okay. This R means the reflection of the quadrilateral FGHJ with the x-axis being the mirror. Okay, so imagine that you're looking into a mirror. If you're closer to the mirror, it appears like your reflection is closer to you, right? And as you back away from the mirror, your reflection backs away from you, right? That's how mirrors work. That's all a reflection is. So, all we're going to do here is to make the reflection of FGHJ is we're going to reflect this with the x-axis being the mirror. So, if you envision, you don't have to draw this on your paper, but just envision this is a mirror right here. Where would each of the points be reflected in the mirror? So if we take a look at point F, which is 1, 2, 3 spaces above the mirror, it's going to be reflected 3 spaces below the mirror. So this reflection would be right here. And we call the point that is the reflection, we call that the image, where the point F is called the pre-image. All right, so anytime I talk about a pre-image, I'm talking about the original figure. The image is after some sort of a transformation happened to it, in this case reflection. So F prime is how it's labeled, F with little half quotation mark, I guess, whatever you call that. I don't teach English, but whatever that little thing is. But in math, we say f prime. All right, and then we take a look at G. G is exactly 1, 2, 3, 4 spaces above the mirror, so its image will be 4 spaces below the mirror. This is G prime. Looking at point H, it's exactly 2 spaces above the mirror, so its image is going to be 2 spaces below the mirror. That's going to be H prime. And then finally, J is touching the mirror, so its image is going to touch the mirror, so J prime. And that just shows you that the image could be the same point as the pre-image point. That's allowed. And now if I were to connect the dots on those, I'm going to connect the dots in the same order, F to G to H to J, but again, F prime, G prime, H prime, J prime. So it's going to be here, to here, to here, and to here. Other than using thicker lines, it looks like a reflection of the object, right? I think the line's thinner. So, it says graph and label FGHJ did it, and the reflection of FGHJ across the x-axis, and then a general rule for reflecting a point across the x-axis. So let's take a look at the coordinates of these 4 image points, F prime, G prime, H prime, and J prime. Okay. What are the coordinates of F prime? Right here.
0, -3.
0, -3, right? And what are the coordinates of G prime?
2, -4.
2, negative what?
-4.
4, perfect, okay. What about H? H prime?
4, -2.
4, -2. And J prime?
0, -2. No,
-2, 0.
-2, 0, very good. Make sure we call out X first and Y second, right? Is it -2, 0? And let's take a look at the original points. I'll just have them right next door. So this was, the original F was 0, 3. The original G is 2, 4. The original H is 4, 2. And the original J is -2, 0. Okay. They want to come up with a general rule. If we're reflecting across the x-axis, how do we make, if we just know the coordinates, we don't have a picture of the graph. Using this particular reflection we just looked at, we want to come up with a conjecture. We think this is how we make a coordinate of an image on a reflection across the x-axis. So if we take a look and compare what we had versus what we have, okay, this is what we had. This is what we have. What changed?
If the y is positive and it's negative.
All right, so this y is +3, this y is -3, the x's stayed the same, right? If we look at the next point, this point's 2, 4, this point's 2, -4, what changed?
The y.
X stayed the same, but y changed, right? And notice positive became negative, right? So x stayed the same in both cases, the y value changed to its opposite. Let's take a look at the next point. This was the original 4, 2, this is the new 4, -2, what changed?
Y value.
2 and negative, the y value again, the x value stayed the same. So that and that. And then finally our last point was -2, 0 and -2, 0. What happened? Nothing changed, right? But 3 became -3, 4 became -4, 2 became -2. 0 can become -0, that means the same thing, right? So even without this having any change whatsoever, if we apply the same thing, make this -0, -0 means the same as +0, right? I probably wouldn't write the negative in general, but I mean, again, if we're trying to create a rule, we want to make a rule that works for all numbers, right? So even though this didn't do what the other ones did specifically, if we do the same thing, we still get the same answer, right? So if I made a general rule for reflecting across the x-axis, so if I say R x-axis, the new point, or the image point, will be x, -y. That's the general rule. That tells me if I see an original point, the new point, x remains the same, y changes signs. If we did that here, x is 0, x stays 0, y is 3, change the sign. X is 2, keep it 2, y is 4, change the sign. So that's the general rule we're looking for there. So, and that's how typically in math we make general rules about things or formulas. We recognize, hey, something happened. Is there some sort of a relationship about how things happened? And then if there is, we can invent some kind of a rule for it. Again, that's just a conjecture at this moment in time. We didn't prove anything, but I will say that that is actually true. So a lot of times you make a guess in math and it ends up being not true for all things, but this is the actual rule for this one.